Assalamu alaikum. In this video tutorial, we shall continue our discussion about measures of dispersion, their characteristics, their limitations, and their benefits and specific circumstances in which these are used. We have mentioned here that for ungrouped data, the population mean is sum of all the population values divided by the total number of population values. So we denote this population mean by this Greek letter mu, which is equal to sum of x divided by n, where uh, x represents any particular value, n is the number of observations. Here we have the example of 12 automobile companies, manufacturing companies in the United States, and the number of patents granted to each of these automobile manufacturing companies. Note that there are total 12 automobile companies and data of all the 12 companies has been selected here. Therefore, this will be called as population because no company has been left, and the data about these companies is number of patents granted to each of these companies. So if we want to calculate the average or mean of the this population, we will use the formula mu is equal to sum x divided by n, which is equal to sum of patents granted to all these companies starting from 511 plus 385 and so on till 13. When we add all these patents, their sum will be equal to 2340, and as there are total 12 companies, if we count them like General Motor 1, Nissan 2 and so on, so till BMW there will be 12. So 2340 divided by 12 is equal to 195. So 195 is the mean of this population. Now we have the formula of sample mean, which is a little bit different from the population mean. Please note that population mean is denoted by mu as we did in the last slide. Here sample mean is denoted by x bar, and we use it when data of all the respondents is not collected. We select only few of them, that is our sample. From this example, it will be clear that Sun Company is studying the number of minutes used monthly by clients in a particular cell phone rate plan. So they might be having millions of clients, but they have selected the data of only 12 clients. Therefore, this will be known as sample. So uh, the number of minutes used monthly by these 12 clients are 90, 77, 94, 91, 110 till 83. So when we collected the minutes used by when we add the minutes of all the clients, we get the answer equal to 1170, as there are 12 clients in the sample. So we divide it by the 12. So 97.5 minutes is the sample mean of this these 12 clients, and this is denoted by x bar instead of mu. Now, what are the properties of this arithmetic mean? The first property is that every set of interval level or ratio level data has a mean. And the second important characteristic or property of arithmetic mean is that all the values are included in computing the means, because we add all these values without skipping even a single value. And the third characteristic is that a set of data has a unique mean. Like other measures of central tendency, mode, or median, mean will be unique value. The fourth very important characteristic is that the mean is affected by unusually large or small data values, which means that if outliers are present, very big value or very small value is present, it will affect the mean value significantly. Thus, we shall conclude that if large and very small values are there, mean may not be a correct representative of the sample. For example, if I want to calculate the average income of five students, there may be 10,000 to 12,000 their average income. But if one student is having average income of 1 billion, then and we include it with the other five students, then the average of this six student may be in billion or near to the billion, while the remaining five students were having only 10 to 12,000. So mean will not be a true representative of the sample if the sample contains very large value or very small values. And the last characteristic of arithmetic mean is that this is the only measure of central tendency. We have other measures of central tendency. Median and mode are also measures of central tendency. However, this characteristic is specific to the arithmetic mean, that this is the only measure where sum of the deviation of each value from the mean is 0. What does it mean? That sum of x minus x bar will be equal to 0, and this is the characteristic which belongs to only arithmetic mean. Now, when we have a large set of observation, it may be cumbersome or difficult or boring to add up all those observations to find out the mean. Therefore, we use the weighted mean. Answer of weighted mean and arithmetic mean will be same. However, weighted mean can be used as an easy method to find out the average or mean of a data set which is having repeated values. Now, formula is that we multiply the weight of each value with the value, and then we add them up and we divide it by the number of values, and then we will get the uh, mean. The example on next slide will make it more clear. Now see here, the Cartel Construction Company pays its hourly employees $16.5, $19, and $25 per hour. This is their wage rate, and there are total 26 employees, 14 of which are paid $16.5 per hour, 10 at the $19.0, and 2 at the rate of $25 per hour. Now, instead of adding this 16.5 by 14 times, we simply multiply 16.5 with the 14, 19 with the 10, and 25 with the 2. 20, and what is the mean hourly rate paid to the 26 employees? So to calculate it, what we do, 14 multiplied by 16.5. So 14 is the weight, because total 14 employees are paid at a rate of $16.50. So we multiply it. Then as 10 employees are paid at a rate of $19, so we multiply 10 with the 19, then we put the plus sign add, and then as only 2 employees are paid at $26 per hour, so we multiply 26 with the 2. We add them up, answer is 471. As total there are 26 employees, this is also sum of their weight. So our weighted mean is 18.1154 dollar. So the mean wage rate of these 26 employees is 18.1154 dollar. Remember, mean is between lower and the highest value. On lower side we have $16.5. On the higher side we have $26. When we apply these calculation, we find that average or mean is 18.1154 dollar. Next are some characteristics or properties of median, which we already know that we sort out the data from ascending to descending order or from descending to ascending order, and then we find out the middle value, which divides the data into two equal half, 50% above the median and 50% below the median. The median is the midpoint of the values. There are as many values above the median as below it. For any even set of values, the median will be the arithmetic average of the two middle numbers. Now, some properties of the mean, like median is also a unique median for each data set, and its important characteristic of median, or you can say the benefit of median over mean, is that median is not affected by very large or very small values. Therefore, whenever in the statistical data we have um, extreme values or we have outlier, we prefer median as a measure of central tendency instead of mean. So it is not affected by extremely large or small values. So the one limitation or problem of arithmetic mean has been overcome by the median. Median remains same whether the largest value increases further or smallest value decreases further. Median is not affected because you know that median is only located at the 50th percentile. So if the last value or the first value or the outlier, they will not affect the median. And it can be computed for ratio level, interval level, and ordinal level data. Here now next we have here a mode. So annual salary, which you know the mode is the most repeated uh, item in a data set. This is an example of the mode that annual salaries of quality control manager in selected states is given. This is their annual salary in selected states. If you see 35,000 has been appeared only once. Similarly, 49,000 has been appeared only once. 60,000 has been appeared 1, 2, 3, 4, 5, 6. So 60,000 have been appeared 6 times as this is the most repeated salary. Therefore, 60,000 will be the mode. Now, relative positions of mean, median, and the mode. If this is a symmetric distribution and skewness is 0, all the three measure will be equal. Mean, median, and mode will be same. This is known as normal distribution. However, if there is positive distribution, then mean will be more than the median and median will be more than the mode, and positive skewness looks like this. And if there is negatively skewed, then its mean will be less than the median and median will be less than the mode. Now, one limitation of the mean was that it was affected by the outlier. The second limitation of the mean is that it does not have additive property. If we calculate a return of 3 years and then we calculate the return on the basis of last year, third year, and the first year, the answer will not be same in arithmetic mean. Geometric mean overcome this problem, and geometric mean is used when we have the data in percentages form, ratio form, or growth form over time. As you know that most of the time in business degrees, we have to deal with the percentage change in sale, cost of sale, the salaries, the GDP. Therefore, you prefer the geometric mean to be used as a measure of central tendency. Its formula is this one. We multiply x1 with x2 till xn and then we take their root of n. Then answer will be the geometric mean. Now, this is an example. Suppose you receive a 5% increase in salary this year and 15% increase in salary next year. The average annual percent increase will be calculated by 5%. Also 1.05 multiplied by 1.15, which is 15% increase. Next year we will multiply them, and these are two values. Therefore, we take their square root, and answer will be 1.09886. If we subtract 1 from it, so their average will be the 9.88. However, if you calculate the arithmetic mean, you will do 5% plus 15%, 20 divided by 2, 10%. So arithmetic mean will be 10%. However, geometric mean is little bit less than the arithmetic mean. So here remember that geometric mean will be either equal to the arithmetic mean or it will be less than the arithmetic mean. Here we have the second example where return on investment earned by Atkins Construction Company for 4 successive years were 30%, 40, 20%, 40%, and 200%. By 30%, we take we multiply these value, take the fourth and the root, and get 1.599, which is 59.9%.